Okay, so hello everyone. I'm Colin Evrard, one of the employees at Might. And today I'm going to talk to you about my experience turning the microbit into a BLE microphone. I walk you through the steps I've taken to try to do that. You can see there is Javad mentioned. That's because he was kind of overseeing me because he's a more experienced colleague and I'm still a bit new to the Zephyr world. So yeah, he's not here today, just me. It's okay. So a word about me. So as I said, I'm an embedded software engineer consultant at Mine. I did a lot of stuff in C, C++, including some high performance server stuff. But these last few years, I've taken a shift in embedded. And so I started working at Mine in January of 2025. My profile is that, well, that does not say much, but I consider myself kind of a jack of all trades, trying to get on board onto every cool stuff that I see, including Zephyr. And I don't like God dev. Who does? Yeah, generally I like reproducible stuff. I also have a talk with Hugo Cornelis at FOSDEM tomorrow, if you're interested in reproducibility. He's also a colleague at mine. Yeah. So about Mind, we are a company situated in Leuven. We specialize in embedded open source software, things that embedded news, build routes, and a lot of everything embedded open source, basically. Come visit us if you want to meet us. So for a bit of context, I got to know Zephyr when I started working at Mine. And so to train myself, I started, like everyone, building some pre-key centers and stuff like that. And I ended up trying to make some basic communication with Bluetooth, low energy on ESP32, stuff like remote joysticks, stuff like that. It's kind of cool, but BLE it seems like a very deep knowledge. So I tried I started this project to increase my knowledge in BLE, and I got comfortable with the Zephyr to the point where I made a small contribution in Zephyr, really small, just an additional check in ADC driver key ESP32. Still add something to Zephyr. And yeah, so at Mine we cultivate expertise. So whenever we have to do training, we try to push the boundary of what we know. And so in that context, I wanted to do a more significant contribution to Zephyr to train myself. So first step was to look around for what kind of boards I had at my disposal. And it turns out that in one of my drawers at home, I had a Microbit V2 laying around. So I started looking into it. Actually, it's quite a nice piece of hardware. It's tied to the history of ARM because it can be considered a spiritual successor to the BBC Micro, which was I'm too young to know about that, but I looked up some stuff and yeah, it was one of the first ARM computers used for the education on the UK. And yeah, so this microbit here is an education-oriented board. So it's mainly made for stuff like MicroPython and a lot of more easy-to-use programming and languages and tools. But you can also, of course, use it with a Zephyr because it's just it's an RF52 chip and it's widely supported in Zephyr, so there's no reason. And also, what's really cool about it is that it's easy to access because when you order a chip of Amazon or whatever thing, you don't really know if you're going to get exactly the same board as the reference one. But if you have a BBC microbit, you're sure that it's a BBC microbit. And they have nice schematics available on GitHub and stuff like that. So it's also cool to learn from that point of view. And yeah, it's used for lots of stuff. Small robot cars to teaching some university course. Actually, at my university, UC Louvain, they use the BBC microbit as an introduction to the first year students to the all IoT stuff, etc. So it's a cool project. It has some nice specs, some flash, RAM, etc. But it's an NRF52, so nothing too uncommon here. But what's important is that it has a 2.4 GHz radio that we can use to do some stuff with Bluetooth and BLE or stuff like that, which is crucial for what I'm going to explain. One thing I haven't mentioned yet is that there is a MEMS analogic microphone on this board. So that's going to be useful to do something related to audio, which is also a subject of interest for me, and mostly 42. Because the microbit is so well known, if we start doing cool stuff with Zephyr on the microbit, it should translate to some Zephyr awareness, hopefully. And yeah. So first step for me to look for something to contribute was comparing the what is supported on the Zephyr page of the BBC microbit to what's actually in the BBC microbit. And as I said, there is a lot of schematics and a list of all of the stuff that there is in the microbit. So it's practical for this kind of objective. And yeah, actually, I didn't see the MEMS microphone on the Zephyr page, so I investigated a bit. I wondered why. And I asked some advice. No, I forgot to step. So I investigated why, and actually it's just an analogic microphone. There's not much stuff to do except just get the signal from it in an ADC. So, but still to get sound out from it, it's not that easy. So I asked another Zephyr enthusiast at Mind Titouan here if he knew about an already supported system in Zephyr to sample PCM audio, and it's in like not out of the box at least, so I set up to just do just that. A word on Zephyr audio input support. There's a lot of support, including for audio codecs. But most explicit support for audio in Zephyr is for audio data in digital format, which makes a lot of sense. But for that particular use case, it did not help me, especially since the MEMS microphone on the microbit is hardwired to an ADC GPIO pin, so I cannot use on that chip. There is on the NRF52 833, there is a PDM module, but it was not easy to connect the microphone to that PDM module because of how the microbit is built. So I set out to still do some simple PCM sampling. So something that needs to be really taken care of when you do software PCM sampling is that you cannot sample with a frequency higher than your CPU, obviously. And your timing needs to be precise, otherwise the audio will not be of high quality or even recognizable. And you have to decide whether you will store the audio sample, the PCM samples, or whether you will stream them. If you store your audio sample, well, you need some space, which is not always easy to get on a embedded device. So streaming it to something like Bluetooth or jack seems to be a good idea. But at first, I wanted to simply go with the storing idea. So this is the path that overall the data takes. We have some sound. It's picked up by the MEMS microphone. It goes to the ADC pin. It's sampled at some frequency, and then we store or retrieve it. So what I can do with that with those stored PCM samples, that I can replay them on the small speaker. It's actually a piezoelectric speaker, so not that good. On the microbit, which is connected to a PWM pin. So my naive implementation was to fix a sample rate. 4 kilohertz was a good starting point to recognize human speech, at least. I fixed the max duration of the recording of the audio samples for a 4-second sample, if I remember well. And I used the busy wait to be sure that the timing is precise, which is not a good practice, but I talk more about it later. And after a while, I was able to replay the person on the speaker, but it was really low quality, not very loud, so it was kind of hard to diagnose, to estimate the quality of the recording. So some things I could improve. The main problem of that approach was that I wasn't using DMA, so I was copying buffer all around, which is a huge waste of resources. So is busy wait, because no other thing can be, the board cannot be used while it's sampling audio. And the speaker quality, as I said, it's really difficult to diagnose potential issues with the sampling code because of how bad it is. So my first approach was to transfer a wax sample in base 64 serial, which was really easy to do thanks to Zephyr rich ecosystem. Just a few things to select in kconfig, and there it was. But it still was an involved process to get those samples. So the whole loop of development was still really slow because of the quality feedback. So what I did to fix these issues, I decided to stream the audio to Bluetooth to use less buffer space. I used DMA, which was straightforward because you could just have to give a pointer to the ADC red async, and for that board at least, it's using DMA out of the box. And I used a timer to pace the samples. I will explain later what I mean by that. And I used an async read for the ADC to avoid wasting CPU resources. To get the sound out, I encoded the PCM samples to LC3, which was once again easy to do with Zephyr because there is support out of the box. And I wanted to try some cool stuff on the BLE side, which is the BAP broadcast source profile. It's also known, at least I think it's not clear, as Auracast. I don't like having multiple terminologies for the same thing like that, but that's the way it is. So about the sampling code, it's quite simple. The first part of this sampling loop is, like I mentioned, the PCM sampling pacing. I simply have a timer that's repeating at the same frequency as the sampling frequency. That will wait here at the K-timer status sync in case we are sampling too fast. Then I wait for the last sound sample that was captured with the polling call, and then I reset the pulse signal, and I try and I set up stuff for the next capture in a loop, and it seemed to work just as well as my previous code, but much more cleanly. Yeah, that's the stuff I just talked about. Now, talk about the BAP microphone that I wanted to implement. So BAP stands for Basic Audio Profile. It's part of the BLE BLE audio specification. The support is increasing, it seems, but not yet. It's not yet everywhere. For example, in my laptop, there was a Bluetooth adapter, but it did not support some kind of specific Bluetooth advertisement that were needed for that. So it was kind of a pain to set up something to test this Bluetooth streaming. And you can do sound broadcasting and sound unicasting. Unicasting, it's not that different from the classic audio sound streaming that we are all used to. But broadcasting can enable a lot of stuff, like having a conference room with only one Bluetooth audio stream. You could imagine having a set of connected headsets for people to hear each other in a noisy event. So it's an interesting technology overall. And the RC3 codec is, well, people say it's really good. Yeah, it seems good. I don't know that much about audio codecs, so. So my first step to add the BAP broadcast capability to my Zephyr project was simply to integrate the BAP broadcast sample into it. There's a lot of samples for Bluetooth. I guess you all know that. It was really easy to do. But actually, I should have done it the other way around. Integrate the audio capture into the BAP broadcast sample in retrospective. And I also fixed the scope because that particular sample has a key config definition to say the frequency, the codec, and whether we want USB sound input or not. So I managed to reduce the code quite a bit. Everything compiled. There was no error in my logs. So time to test it out. But that was actually the real problem. So the real problem with Zephyr is outside of Zephyr. So I was using Debian 12. People always ask me why I don't use Debian 13. It's because it wasn't out when I installed my computer, and it's still it's not end of life, so I don't see why I would upgrade. Yeah, I know, amazing. And I had to enable Bluetooth the experimental features in specific config files. I think it's also you still have to do that with more recent versions of Debian and other Linux distros. And you have to use Pipewire with some specific LC3 plugins to be able to get LC3 sound out of the Bluetooth service, which is usually bluesy. Yeah, so after a while, I managed by following these steps, I managed to get the LC3 audio scene profile that shows up in the doc. So should be good. But actually, I haven't found a way to still connect my BBC microbit with Bluetooth to it. So I tried something else. I don't know. It seems kind of an obscure project. At least it doesn't have enough stars on GitHub. Should have more. Bumble is a Python CLI tool by Google, which gives you access to a full Python Bluetooth stack implementation with a strong focus on Bluetooth LE. They are starting to add the support for normal Bluetooth, it seems. And on their website, on the documentation. In the documentation, I mean, they propose to use an nRF52840 in case you don't have a Bluetooth adapter that has all the necessary features. And they actually suggest to use the HCI USB Zephyr sample. And it turns out that I had also an nRF52840 lying around. Exactly, that was kind of lucky. And so I could flash it with the HCI USB profile and use it as a Bluetooth controller on my computer. I needed to enable also some specific advertisement for BLE audio. And in the end, I managed to see my broadcast with it, but I don't want to see my broadcasts. I want to hear them. But it's a bit more complex than that. So, BLE is big. It's a complex system. It's time-consuming to read everything, but it's quite manageable because of its clean documentation on the Bluetooth website. It's still a technical reference, so it's not your bedtime book, but it's clear that some things and a lot of things. And this is where we discovered all the trigram acronyms in the BLE stack. So I put mostly the ones that I had to investigate for this project. So we had BLE, which contains the Bluetooth audio profile, which contains the CAP initiator profile, the public broadcast profile, and the Auracast, or the Bluetooth, the BLE broadcast source and sync. But one thing that I really struggled with was actually finding a reference implementation that works for testing Bluetooth. Even like having some well-known adapter I could buy that I know has a good implementation would have helped me a lot, but it's messy. Especially if you search for Auracast stuff. There is some stuff, but I'm not going to buy 150 euros pair of earphones just for that. Yeah. It would be nice to have a reference implementation, and when searching on Google, it seems that right now the reference implementation is Zephyr, at least according to Google. That's good. And yeah, as I mentioned, the different names for the same features is with Bluetooth is really annoying. To really, it took me like the whole day to realize that BLE broadcast was used, and it was called Auracast. And if you don't know it, it's difficult to find. But sadly, I never managed to make a good demo because I could not play. So everything looks good on my logs. I inspected the debuggers. There are encoded C3 buffers floating around my CPU, and it should be able to be streamed. But when I try Gitbumble, it sees the stream. When I try to receive the stream and audio, it says that its status is pending. And when I actually scan, so I do not receive, it says that the broadcast has started. So there is something going on there. I don't know what exactly. I suspect it's some sort of different implementation. Maybe the order of the advertisement is supposed to be fixed or something like that. To really be sure about that, I should look into the code of Bumble. Also, probably the Bluetooth stack of Zephyr, and I will hopefully find why I cannot listen to my audio broadcast. But yeah, as I said, it's difficult to really try to test that kind of things if you don't have something you are sure works the way it's intended with Bluetooth. And yeah, so I will upload my source code shortly. I haven't had time to clean it yet. I don't think anybody wants to read my ugly code in that state. But I will upload it on that repository in the next few days. If case you are interested, what is the ADC sound sampling? Which is actually a discussion to be had. Like, should I be like a subsystem for in audio for sampling BCM sample that's specific to audio, or should it be considered like a generic signal processing stuff? In that case, should it be with the rest of the sensor in Zephyr? It's not clear to me, but I think even as a sample, it would be nice to put it in Zephyr. And that use case could be useful for some other things that could be pulse code modulated, not only sound. And yeah, BLE is difficult. I'm not the first one to say that Bluetooth is difficult. I'm not the last one. Hopefully, I will have the complete demo next year. Well, it should be completed before that, but I will have to wait to present it again. One of the I am taking this occasion to say that the approach that Zephyr has with the samples is really great, because you can combine them like you want. They are well explained, and it allows for a really hands-on approach, which I think a lot of developers like. And it allows to dive quickly into complex topics like Bluetooth by focusing on what you want and not reading the gigantic technical specification. So thank you for listening. Do you have questions?
Could you put the slide as the URL?
Yeah.
Thank you. Look to any. Yeah, how was your experience upstreaming? Like, do you find friction getting your code in?
So the code for the microbits has not been upstreamed yet.
Your ESP patch, for example. Your ESP patch.
Yeah, my ESP patch. Oh, it was really nice. I've had a much worse experience streaming open source stuff. But straight to the point, there was a few things to fix here and there, and the people that reviewed it told me in a nice way. So yeah, was hurt.
You said there was already support for the SC3 codec, but that's the codec for this kind Bluetooth audio. But there's no support for the Bluetooth audio, so why did Sony the first step?
Possible. So you figure it?
Wow, the people who implemented that codec, what were they using it for? Do you know that?
I think that people managed to make the sample, the broadcast, Bluetooth audio broadcast sample in Zephyr work in some other context. I don't think the provider is in Zephyr, so actually, I think the LC3 codec in Zephyr is meant to be used with the Bluetooth stack of Zephyr. It's supposed to work. I believe it's mostly a problem of having compatible Bluetooth stacks on the receiver and sender.
Yeah, so the split.
Some P.
Oh,
Sorry.
and was it? He actually, in the development of the Bluetooth stacks, they have been using Zephyr for the past 5 years to prototype things before it was published as a standard. And so the Zephyr one, I think, is probably like be close. I've talked to see people directly on this in terms of where else it's been proven out. But before they published the standards, like the audio and so forth, they were all prototyping everything in Zephyr, which is probably why your search said it was a standard. But yeah. But I don't know how much bumbles. But I don't know. I put that in the so I know.
I think that I see the developers in remember GitHub blame a lot the Zephyr stack. into.
Oh, like I say, because they're doing it, it's bleeding edge. It does get bugs. So I'm not gonna say it doesn't. But on the other hand, before they release the spec, they have prototyping that.
Yeah, and sometimes respects both sides can be right. It's just a matter of other piece.
That's it. The down to your spec. That's the result. Yeah, exactly. I expect.
Just a comment also, the Bluetooth audio stack is very complicated because there's simply the audio streaming, which must be time synchronized and stuff, but there are all the auxiliary protocol to establish the topology of the sound network, to actually get some streams, start streaming, to connect, and that's probably getting all the pieces to work together. That's the most complicated part.
Yeah, I saw a lot of complicated profiles and the BLE specification for that.
To pick up on that, if you want to have like a reference sample of Bluetooth audio, you have the Nordic and then a 53 kit that has like dedicated with audio codecs and inputs, outputs, samples, do broadcasts and all that stuff. And also I remember that there is some hardware specific stuff in the Bluetooth stuff, because you need to synchronize your sampling with the isochronous sampling, with the isochronous packets. And most Nordic devices don't have that. So he did the 53 that does have that.
I've seen, so I try to enable this synchronizable adjustment, I think it's called, in Kayat. I mean, it seems like it was not support on my chip, so maybe that's the reason. But it's not clear on the specification part, was maybe it's clear on the specification that from an outsider, it's difficult to know that exact detail. But yeah, it's good idea to put this on the shopping list for mine.
Yeah. Also the headphones, you ordered them via mice. You know, you're also, and the headphones there do the power.
I need those ones at 300 euros.
Yes. Too much noise in the office.
Okay. If that's all with the questions.